So in this video, we continue our discussion on how to find the volume of a solid by the method of cylindrical shell. And let's look at the current picture. The purple part is bounded by two lines. One line is y equals 2x, the other line is y equals x squared. And let's look at the axis of rotation. In part A, we'll look at the volume formula by the cylindrical shell based on the x-axis rotation for the purple region here. So now please recall what you do with the cylindrical shell method. And the cylindrical shell method is always based on a red line which you need to draw to parallel to the axis of rotation. So when you draw a red line like this, when you rotate this red line along the x-axis, what you are getting is something like a horizontal cylinder, right? And if you recall the formula to this case, the formula in this case is based on how you count the surface area of a shell. And because it's an x-axis rotation, you see, such a line you can draw from the lowest point all the way up to the upper point. It gives you a sense that you're counting the surface area of a shell based on the location of this kind of horizontal line. And it gives you a sense that it's a summation, which informally speaking as a summation and mathematically is an integration um, of dy, because you have to add along the area of all the shell based on the lowermost shell, which is the lowest point, and which means A is 0, up to the uppermost point, which is B. And please tell me how to find the B. The B is what? The B is the y coordinate of this point, which is the intersection of these two lines. So I think mathematically we can solve this problem. To find the y coordinate of this point, I can set them equal now, and you can solve it by looking at this degree 2 polynomial, and there are two solutions, 0 and 2, and obviously b is not 0. I mean, b is based on the x coordinate 2, and when x is 2, you have to replace it back to one of the lines here. Doesn't matter, maybe I choose the first line, y equals 2x, so x is 2, so it means y is 4, right? And b is basically the on the y-axis, which is 4 now. We understand it, so I'll just put 4 here as b. And what is the content inside the integral? The fact that now for the x-axis rotation, it should be 2 pi y times something. This something represents the height of the cylinder. Let's look at this black box. You see the height is essentially the horizontal length of this black line. And let's come back to this two-dimensional figure. It's essentially such a line, right? If you look at this line, the length of this line is basically the difference of the x-coordinate of these 2 points. And please look at this point first. This point, the x-coordinate is based on the function y equals x squared, or the other way to say is based on x equals square root of y. And we have to use it because we have to look at the x-coordinate instead. And this x-coordinate minus the x-coordinate of this point. This point is based on this line. And y equals 2x, we have to make it like x equals something in y. So I think you can transform it to x equals y over 2, right? So basically, the h is basically the same as the outer line, which is x equals square root of y, minus the inner one, which is y over 2. It is the length of the horizontal line h here. And I'll just put it here, square root of y minus y over 2. And that's the answer to this problem part A. And let's look at the same picture. Let me change the axis of rotation and we can talk about that. So please look at the current problem. I'm just taking the same picture as before, but now instead of taking the x-axis as the axis of rotation, I'm now pushing the axis down by 1 unit to the line y equals minus 1. And please look at the method of cylindrical shell. It is not changed much. You see, you have to pick a line parallel to the axis, and the axis is parallel to x-axis. So basically, we're picking the line same as before, and each line after rotation from the horizontally placed cylinder we want, right? And that's basically one shell here like this. And let's look at our formula. The concept is not changed much. I'm just pushing the axis down by 1 unit. So I think it is still a dy integration first. And second, these 2 points must be the same, because if you look at the way you pick the horizontal line, it's really the same. It's really the same, starting from the lowest point to the upper point here. And we found it already. It's like from 0 to 4. And let's look at the content inside the integral. You see this part is the height of the cylinder, which is the horizontal length of this shell. And if you come back to this picture, you see this length is the x coordinate difference between these 2 points. Essentially, you have to look at the x equals square root of y for the x coordinate of this point minus um, x equals y over 2, which is transformed from this equation for the x coordinate of this point. So basically, I'm saying that the height h of this cylinder is the same as the part A, which is square root of y minus y over 2. But the main difference is coming from this part. This part is what? So I use a black color. This part is basically the radius of the circular cross-sectional area, which is this part. This part is basically the B. I mean, maybe I use the B equals 2 pi r, and this one is basically r, right? This is the radius of such a circle, and if you come back to the two-dimensional picture, this is basically our r here. And how to find this r? You see, you have to one to the original r that you got from the last part A. And usually in part A, we just wrote the y as the r because I'm essentially just taking the height of this point like this. You see this point? So it is just y, but you have to add 1 because of the fact that I pushed the axis down by 1 unit. So basically, that's the end to this problem. It would be very beneficial for you to compare the answer you have in part A and part B. There's only one main difference, which is this part. And that's the end of this video.